Alright, so we are going to try this a new way since we're not in the classroom anymore. So this is going to be our notes to finish up 2.1 in our equation section of our book. We're going to go over examples 3, 4, 5, 6, 7, and 8 in this section, and then we'll get to next unit, or next section will be on 2.5 that I'll post those notes for. So a couple things before we get started. Okay, you can use these. You can use the videos in the e-text. Those are kind of helpful too to help you with your homeworks. I will be doing your office time, my office time for you guys. Right now is going to be on Mondays from 6 to 7 on your Blackboard Collaborate. '13, 14. Okay, so anytime you want to jump in on that, so if you have any questions, you can email me, then jump in on that between 6 and 7. I can help you with those. It'll be on Mondays, and we'll set up an extra time if we need an extra time somewhere. But I'm hoping that I can get most of your questions done on these little notes. So as we get into this section 2.4, we need to kind of review a couple things. One, our slope-intercept form. The slope-intercept form. Y is equal to mx plus b. M is my slope. Remember, b is my y-intercept. And then we have our point slope form, which is the y minus y1 is equal to m times x minus x1, in which m is again my slope, and then x1, y1 is the point they give us. Okay. Now, examples 3 and 4, though, also talk about parallel and perpendicular lines. Okay. Remember, parallels have same slope, and perpendiculars have opposite, reciprocal, and equal slopes. In other words, 2/3 opposite reciprocal of that is -3/2. We just flip it, right? So when we look at example 3, it asks, and you can look in your book and see where this is at, but in example 3 it asks us to find whether or not the lines are parallel, perpendicular, or neither. And they give us two lines. 4x plus 8y is equal to 10. 2x is equal to 12 minus 4y. Now the easiest way to deal with this is just find the slope and let's use the slope-intercept form, because that's the easiest one to get things into. And we're going to look and see what m is when I get it into that form. So I got to solve for y. Alright, so if I'm going to solve this one for y, I'm going to move the 4x over, divide everything by 8. I'm going to get y is equal to now -1/4. Use those calculators. You all have those calculators. I believe one of you all have one of my calculators, which is fine as long as I can try and get that back by the end of the semester. We're going to reduce that. That's -1/2. And then this out here is going to be 5/4. Alright, so we're going to do the same thing with this one. Get y by itself. So we're going to move the 12 over. 2x minus 12 is equal to -4y. Divide everything by -4. And notice we get -1/2 x plus 3 is equal to y. And remember what we're looking for. We're looking for the m. Here's the m. Here's the m. Are they the same? They are the same. Since they're the same, my answer over here is that they are parallel. Okay? So that's all we have to do. Not going to graph it, not going to do anything else. Now, remember, you guys can graph these in your graphing calculator. Go to y is equal to. You can type that in, so that would be your y1. This would be your y2, and you would notice that they have the same slope. Okay, they are parallel. So, example 4. So example 4 is asking us the exact same question. Okay, and they've given us this equation, and they're also giving us this equation. Now we already know what this one is. This is y is equal to negative 1/2 x plus 5/4. We already did that one. Let's not reinvent the wheel. Solve for y in this one. So this would be negative 2 is equal to negative 4x plus 21. Divide everything by negative 2. We're going to get negative 4 over negative 2 is 2x plus 21 over 2. Now remember, the only thing we're looking for is that m. This value, that value. Are they the same? No. Are they opposite reciprocals? Negative 1 over 2, 2 over 1. Do I flip them? Yes. Are they opposite signs? Yes. So these two are perpendicular. And I like to use the symbol upside down T. Okay? Now, if neither, if neither one of those happens, if they're not perpendicular and they're not the same, then you would circle the neither. Okay? So, that is examples 3 and 4. Alright, so let's now go to example 5. Okay, so in example 5, they want us to find an equation of a line in standard form. We'll talk about standard. We talked about standard form before. We'll talk about that when we get there. Okay, we're going to have the line is going to have a slope of negative. I'm trying to read it myself. That's a negative 5/3, and goes through the point P at 3, negative 1. Okay, so if I have a slope and I have a point, then we want to probably use this. It would probably be the easiest thing for us to do. Point slope form. This being x1, this being y1. Go ahead and plug everything in. It's going to be y minus a negative 1 is equal to the slope times x minus 3. Now, x minus a negative 1, that's positive 1, right? Two negatives give you a positive. Okay, and then I'm going to distribute. Now we're going to make this easy. Okay, there's no reason for us to fret about this. That's going to be negative 5/3 x. Negative times a negative is positive. And if it was me, to save myself time and make sure I don't make any errors, use your calculator. 5/3 times 3 is 15 over 3, which is 5. So it's plus 5. Okay? Now, what do we do with this after that? Okay, well, we need to get everything together, so I'm going to go ahead and subtract the 1. I get y is equal to negative 5/3 x plus 4. Now, that happens to be my slope-intercept form, which sometimes they may ask you for that. That would be done. But standard form, okay, we've talked about standard form. Talk about it again. Is ax plus by is equal to c. Remember, and all these have to be whole numbers. So I just have to get the x's and the y's on the same side. So I'm going to move the x over. 5/3 x plus y is equal to 4. And then remember, no fractions. So we're going to multiply everything by 3. We're going to get 5x plus 3y is equal to 12, and that is standard form. Okay? So we both have both forms, standard form and slope-intercept form, depending on what the question asks you for. Okay? Remember, no fractions, and then this also has to be positive, which it is, so we're good to go. Okay? Alright. So, question 6 then. Okay? Question 6, so we're trying to play a little catch-up. I know we're going a little fast, but you can always stop this and replay it if it get a little too fast for you. Okay? In this one, they want you to find find the line that goes through 2 points, P, 3, 7, and Q, negative 5/3, and they want the final answer in standard form. Okay, so I'm given 2 points. Okay, the one thing we don't have is we do not have a slope. We need to find a slope. Okay, remember your formula for 2 points of a slope. Okay, you can either plot it, which takes way too long, but remember y2 minus y1 over x2 minus x1. This can be my x1, y1. This can be my x2, y2, however you want to label it. Okay, so as I plot, okay, we're going to go 3 minus 7 over negative 5 minus 3, which is going to be negative 4 over negative 8, which is 1/2. Okay, so we've now found our slope that we're going to use, and what we get to do is we're going to use this as my m, my slope, and we're going to pick a point. And it doesn't matter what point you pick. And the nice thing is you can pick point P, you can pick point Q. Pick the easy one. Okay, so let's just say we're going to pick point P. Okay, so we're going to get y minus 7 is equal to 1/2 times x minus 3. Okay? Alright, so now what we're going to have to do is have to distribute because they want it in standard form. So we're going to distribute. We're going to get 1/2 x minus 3/2. Now, most of y'all don't want to work with the fractions. You got a calculator to deal with the fractions, and that's not a huge issue. But if you don't want to work with the fractions, let's multiply everything by 2 to get rid of fractions. So, you know, that fraction phobia. So this is going to be 2y minus 14 is equal to x minus 3, which is actually going to be helpful because in standard form we don't want the fraction. We're going to move the x over, move the 14 over by adding a 14 over here, and we're going to get 11. Okay? Now, we do want this in standard form, so this has to be positive, so we're going to multiply everything by a negative 1, which gives us x minus 2y is equal to negative 11, and there is my standard form. Alright, so the next question we're going to deal with is we're going to deal with numbers 7 and 8, but what we're going to do is we're going to simply just do number 7, but we're going to do it 2 different ways. Okay, we're going to incorporate number 8 into number 7. Okay, so that we can be done with this section. Okay, so what they want in number 7, what they want us to do. Okay, this is example 7 in your text. Okay, and so what they want us to do, they want you to find the equation, find the line that passes through the point negative 2, 5 and is parallel to the line y is equal to 8x minus 3. Okay, so in this one we got to find 2 things. We got a point. Okay, so here's our point, and we need a slope. Well, what do we know about parallel? Parallel lines have the same slope. So my slope here is 8. So that's the slope we're going to use. Okay, so we're going to take the point, take the slope, put it in your slope point slope form. This is your x1, y1. So y minus 5 is equal to 8 times x minus a negative 2. Now remember, x minus a negative 2 would be x plus 2, correct? So we can change that to a plus, and we're going to distribute the 8. Okay, so it's going to be 8x plus 16. Okay, now This one, they want the answer in slope-intercept form, which is y is equal to mx plus b. So I just need y by itself, which is a whole lot nicer because all I have to do here is plus 5. I can have fractions if I need it. That's not a big deal. But here's my slope-intercept form for number 7 as I add 5 to both sides. Now, what number 8 wants you to do is then have the line perpendicular. So what if perpendicular to y is equal to 8x minus 3? Well, that means if that's my slope, then my perpendicular slope would be negative 1/8. I flip it, and we change the sign. Okay, so now we're going to use that as my slope and the point negative 2, 5. So I have y minus 5 is equal to negative 1/8 times x minus a negative 2, which is plus 2, just like before. Same problem, right? Except I'm going to have a different slope. So now I'm going to distribute. So this is going to be negative 1/8x minus 1 over 4. Okay? Now, to put this in slope-intercept form, I have to add 5 to both sides. Here, I would highly suggest going ahead and putting that in your calculator, especially now that we're not in the classroom. Okay? Negative 1/4 plus 5. Your calculator, make sure it's in fraction form, should give you a 19/5. And you are in the slope-intercept form. Okay? Now, that would be an ugly one in standard form, by the way, but you could put it in standard form. If they said, what if standard form? I'd have to take this whole equation, first and foremost, multiply everything by 40, which is that common denominator, right? So if I multiply everything by 40, this would be 40y is equal to negative 5x plus whatever 19 times 8 is. Ugh, 72. Why did I do this? 152. Okay, and then move the x over, and this would be 5x plus 40y is equal to 152, and that would be the standard form of that same equation. Alright, so that does end the 2/4 part, okay, of the things that you need to be able to deal with and do your homework in that part of anything that says 2.4. Okay. And next one we will be doing will be on 2.5.